welcome to the material session of Upalsa's career point. This is a video for the student of class 11 on unit 2. The name of the unit is atomic structure. This is the fourth video of this chapter covering the topics Bohr's atomic model, its merits and demerits. Let's come to know what is Bohr's atomic model. First atomic model was given by J.J. Thomson. After his failure, Rutherford gave his atomic model. And after the failure of Rutherford's atomic model, Niels Bohr gave his atomic model by taking into consideration the quantum theory of radiation proposed by Max Planck. The main postulates of Bohr's atomic theory are: an atom consists of two parts, such as the nucleus and the extranuclear part. The nucleus is positively charged and is present at the center of the atom. The electrons are revolving in the extranuclear part in definite circular path known as cells or orbits. According to Niels Bohr, ଗୋଟେ atomର ଦୁଇଟି part ଅଛି, ଗୋଟେ nucleus ଆଉ ଗୋଟେ extranuclear part. The central massive positively charged part, which is made up of neutrons and protons, is called the nucleus, and the electrons are revolving surrounding the nucleus in several fixed circular paths known as cells or orbit. Each orbit is associated with a definite amount of energy. With a formula, En is equal to minus 313.6 by n square kilocalorie per mole, or En is equal to minus 1312 by n square kilojoule per mole, where n is equal to 1, 2, 3, 4 and so on. When the values of n is equal to 1, the name of the orbit is K cell. When it is 2, it is L cell. When it is 3, it is M cell. When it is 4, the name of the cell is N cell. These orbits are called energy cells or energy levels. As long as an electron revolves in an orbit, it does not emit or absorb energy. So the orbits are called stationary orbits or stationary states. ଯେତେ ପର୍ଯ୍ୟନ୍ତ ଗୋଟେ ଇଲେକ୍ଟ୍ରନ୍ ଗୋଟିଏ ଅର୍ବିଟ୍ରେ ବୁଲୁଥାଏ, ତାର ଏନର୍ଜିର କୌଣସି ପରିବର୍ତ୍ତନ ହୁଏ ନାହିଁ, ଅର୍ଥାତ୍ ସେ କୌଣସି ଏନର୍ଜି ଆବଜର୍ଭ କରେନି ବା ଲସ୍ ବି କରେନି। ସେଇଥିପାଇଁ ଗୋଟେ ଅର୍ବିଟ୍ସ ଗୁଡ଼ିକୁ ଆମେ ଷ୍ଟେସନାରୀ ଅର୍ବିଟ୍ସ ବୋଲି କହିଥାଉ। ଦି ଏନର୍ଜି emitted or absorbed only when the electron jumps from one orbit to another. ଯେତେ ଇଲେକ୍ଟ୍ରନଟି ଗୋଟେ ଅର୍ବିଟ୍ରୁ ଆଉ ଗୋଟେ ଅର୍ବିଟ୍କୁ ଜମ୍ପ ମାରେ, ସେତେବେଳେ ଏନର୍ଜି ଏମିଟ୍ ବା ଆବଜର୍ଭ ହେଇଥାଏ। ଯଦି ଆବଜର୍ଭ ହୁଏ କ'ଣ ହୁଏ ନା ଏନର୍ଜି ତାର ଇନକ୍ରିଜ୍ ହେଇଯାଏ, ସେ ଲ ଅର୍ବିଟ୍ରୁ ହାୟର ଅର୍ବିଟ୍କୁ ଜମ୍ପ ମାରେ। When an electron absorbs energy, it jumps from lower orbit to the higher orbit. The higher energy state of the electron is called the excited state. In the excited state, the electron is unstable. Excited rate electron is unstable रहे. So it jumps big to lower orbit with the emission of energy. So excited rate electron रही पारी, सी energy loss करी lower orbit को पुनी return back करता है. The amount of energy emitted or absorbed is given by the equation delta E is equal to EF minus EI. Energy in the final state minus energy in the initial state कले हमें पाइबो delta E. Where EI is the energy of the electron in the initial orbit and EF is the energy of the electron in the final orbit. If delta E is found to be positive, then it is concluded that amount of energy is absorbed. If delta is found to be negative, it is concluded that amount of energy is lost. The electron absorbs or emits energy of at least one photon or a whole number multiple of it. Either से गोटे photon बा whole number multiple of photon को से absorb करी था. Energy of the photon को हमें h nu कही था. So delta E is equal to n h nu, where n is equal to 1, 2, 3 and so on, and h nu is the energy of the photon. According to Bohr's atomic model, the radius of nth orbit is Rn is equal to n square h square by 4 pi square m e square z. As here z is equal to taken is 1 as a hydrogen like atom. So we can write down Rn is equal to A0 into An square, where A0 is equal to 52.9 pm or 0.529 nm or 0.529 angstrom. So we can write down the radius of the orbit Rn is equal to 0.529 into n square angstrom. By using this formula, the radius of different orbits can be calculated and also applicable to calculate the distance traveled by the electron when it jumps from one orbit to another. The speed of electron in an orbit is given by the expression v is equal to nh by 2 pi mr. Substituting the value of r in the above equation, we can write down v is equal to 2 pi e square z by nh, which is otherwise known as 2.19 into 10 to the power 6 z by n meter per second. The angular momentum of an electron revolving in a stationary orbit must be an integral multiple of h by 2 pi. The electron rotation is permitted in this type of orbit only. Angular momentum mvr is equal to n into h by 2 pi, where m is the mass of the electron, v is the velocity of the electron, r is the radius of the orbit, n is equal to 1, 2, 3, 4 and so on. H is the Planck's constant. Merits of Bohr's atomic model: it could explain about the stability of the atom, it explained about the hydrogen spectra, it helped to calculate the energy of electron in an orbit, it helped to calculate the radius of each circular orbit, and limitation, drawbacks or defects. It does not explain the spectra of atoms or ions having more than one electron. It could only explain the line spectra of hydrogen atom. It explained only electrons are revolving in circular orbits around the nucleus. But modern view shows that electrons do not revolve in the circular orbit. They revolve in three-dimensional part. But Bohr's theory cannot explain this. It fails to explain the smallest division of the line spectrum of hydrogen. It fails to explain the splitting of spectral lines in magnetic field, that is Zeeman effect, and electric field, that is Stark effect. It fails to explain the shape of the molecules and bonding in the molecule. Now, self-assessment 4. After writing this video, you can go for your self-assessment test 4. What is the Bohr's atomic theory? Write down its merits and drawbacks. It is a long question. What is the concept of quantization of angular momentum? What is the distance traveled by an electron when it jumps from k cell to m cell? What is the amount of energy released or absorbed when an electron jumps from L cell to N cell? What is the velocity of the valence electron of sodium atom? Thanks for watching Propulsor's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time. Don't forget to hit the bell icon to get timely updatation of my new video.